All right, so I want to look at vectors in 3 dimensions here, and it starts really with understanding the 3-dimensional space that we graph in, okay? So as you can see here, we have an x and y axis. However, the x and y axis, we're looking at it from kind of a different perspective now. So instead of like this, we've laid it down on its side, okay? So the positive y-axis is going out here kind of to the right, okay? So here's the positive y, if we're zooming in on this one. And the positive x is kind of coming out towards us. If you try to look at this in perspective, all right? Here's the negative x-axis back here, and the negative y-axis is over here kind of to the left and in the back. Our third axis is this z-axis, and the positive z goes up and the negative z goes down. So here we see the challenge of drawing 3-dimensional things on a flat surface, okay? So, all right, but the nice thing is you're not going to be asked to do this. I just want to kind of show you one or two so you can see what the process is here. So if I'm plotting a point 2, 3, -4, I have an x, y, and z coordinate. I'm going to come out 2 on my positive x-axis, and I've got to go 3 on my positive y-axis. And what I would do then is I would kind of create this little grid there, okay? And where those intersect, the z is going to be somewhere along this, okay? Right there are all the points where x is 2 and y is 3, but if z equaled 0, I would be right here. If z equaled 1, I would be up a unit. If z equaled 2, I'd be up 2. Z is -4 in this case, so I'm going to go down 1, 2, 3, 4 units. And that's where the point is going to end up, okay? So down 1, 2, 3, 4, 1, 2, 3, 4. There's my point right there, point P. Okay? So it's kind of out towards us and down. All right, if you could try to visualize that. All right? This is why a lot of times we use computers to help us graph stuff in 3D. Like your calculator doesn't even do 3D. Okay? I'll do one other one for sake of time. I won't do all 3, but okay, here's here's this one. 3, 5, 1. Okay, so I'd come out here 1, 2, 3 on the positive x-axis, 1, 2, 3, 4, 5 on the y-axis, and I would kind of do this grid. By the way, notice when I'm coming off of the y, I come off kind of parallel to what the x is, the best I can. And when I come off of the x, I come off parallel to what the y-axis was. Okay? And then I've got to go up 1. Alright, so I know the z-axis is kind of like that at this point. So if I go up 1 unit, that would put me right there. So there's point Q. Alright? So it's kind of out towards us, but it's above that plane, a little bit higher. Okay? Alright, so really challenging to view, but the nice thing is you won't have to graph anything like this. But I want you to see what we're dealing with, alright, as we work on math. So let's look at some similarities. I put similarities between 2-dimensional and 3-dimensional vectors because all of the math is virtually identical here. Okay? So we have these unit vectors. The I and j we had before. I was the vector 1, 0, and j was the vector 0, 1. Well, now if we're in 3D, I is 1, 0, 0, j is 0, 1, 0, and k, now we have a k vector, that's the unit vector, it's 0, 0, 1. So you can look at this as the horizontal, the I is our horizontal, the j is our vertical, and then k is our z. We don't really have a name for that. Okay?
Yeah.
But let's say we have position vector OP. Alright, we said that if you have the coordinates of a point, you can write it as a position vector. So if I have the point 2, 3, negative 4, I could write that as vector 2, 3, negative 4, which I could also write as 2i plus 3j minus 4k. You should be familiar with all types of the notation here. Also in 3D, we didn't do this as much in 2 dimensions, but in 3D you'll see a lot more often this other notation where we had 2, 3, negative 4 written vertically in parentheses like that.
Yeah, I was gonna. Yeah, I don't.
Remember that we had 4 different kinds of notation. You could use just the parentheses, you could use the little angle brackets, you could use IJK, or you can use the parentheses with it written vertically. All of those are saying the same thing, and you will see all of them depending on the context of what you're doing.
Can they also be labeled something like A, B, C, I, J, K, maybe?
Oh, well, I have X, Y, and Z. You might see AI plus BJ plus CK.
Yeah, I think that's how I did it.
Yeah.
Because I recognize this, and then you have to do multiplication. Like I put it up in like a table, and I don't know.
Yeah, we'll do some of that. Did you guys do a little bit of that? What class was that?
Miss Hen, pre-cal.
In pre-cal? Okay, so you did a little bit of vector stuff there.
Yeah.
Okay.
No, I definitely did vectors. I just didn't recognize when you said parametric.
Okay.
That is.
Okay. Alright, so the other thing that we did in 2 dimensions that we'll do here in 3 dimensions is we found the vector between 2 points. Now, well, you don't have to sketch it, and really sketching it is not even going to be all that helpful here. We can find the vector between 2 points the same way that we did before. You take the position vector to the point you're going to, in this case would be B, minus the position vector to the point you're coming from. Okay, and since the position vectors are just the coordinates, notice here we have x2, y2, z2 minus x1, y1, z1. Alright, so the point 2b is where we're going to, and we subtract the coordinates of the point we come from. Alright, so in this case here with AB, if I want vector AB, I'm going to do the coordinates of point B, so negative 3, 2, 3, and I'm going to subtract the coordinates of point A, so 1, 5, negative 2. Okay? Same thing we did in 2 dimensions. Now we just have a third component. So vector AB would be the vector negative 4, negative 3, positive 5. Okay? What would, this is a matter of review as well, what if I did vector BA? What would that be?
1 minus negative 3, 5 minus 2, negative 2 minus 3.
Okay, yeah, we would have 1 minus a negative 3, we would have 5 minus 2, and we would have negative 2 minus 3. 4, 3, negative 5. What do you notice about that?
They're the same, just opposite signs.
Yeah, they're the same as AB, just opposite signs. And that's because if I have the letters in reverse order, all I've done is change direction. So instead of going -4 on the x, I need to go +4 on the x. Instead of -2 on y, I got to go +2 on the y. So here, this is just a negative AB. It's the opposite direction. Okay? Now, the other thing that we had done is we found the magnitude of this vector. Okay? The magnitude of the vector is the distance from A to B. Okay? Which, remember, the notation for this is also AB like that. But notice, this is just our distance formula. We've used that back in Algebra 2 even. Or actually even back in geometry, I think. But we only did 2 dimensions. Now it's just a third dimension, but you're doing the same thing. You subtract and square. Okay, so if I want to find the magnitude of vector AB, I'm going to take, and I have 3 sets of parentheses squared, and I'm adding them all up. This is an extension of the Pythagorean theorem, by the way. Something squared plus something squared, we just have a third something squared added as well. But then I take the coordinates of A, which are 1, 5, and -2.
Is this not the distance formula too?
Yeah, it is.
Okay.
Yeah.
Because I kept going to say it the other day, and every time I didn't say it because.
No, it is. The magnitude of a vector is the distance between the endpoints.
Yeah. Okay.
Yeah.
That's what I thought.
So 1 minus a -3, 5 minus 2, and -2 minus 3.
So when you're trying to find the vector of AB, you do the B components minus the A ones, and then if you're trying to find the magnitude, wait, what are you finding right now?
I'm finding magnitude.
And if you're trying to find the magnitude, you do A minus B.
It really doesn't matter. Why does it not matter here which order I put these in?
Because it's all addition in between them.
It's addition between them, true. But like, why does it not matter if I put -3 minus 1 instead of a 1 minus -3?
I don't know.
What am I doing after I subtract it?
Squaring it.
I'm squaring it. Okay? If I reverse them, it's just going to make it the negative. Right? So if I square it, the negative's gone. So here, don't worry about which order you're putting it in. And it really goes back to this. AB and BA are the same vector, just opposite directions. And they're going to have the same magnitude. Okay? They're going to have the same magnitude. So, again, doesn't matter which order I put them in. So I have 16 plus 9 plus 25. So that's the square root of 50, which is 5 root 2. Okay? Now, here's the nice thing with this. If I already have written down what the magnitude is, or what the vector itself is, okay? If I've already written these down, I already have what those subtractions equal. I have the 4, the 3, and the -5. So I could just use those straight from my vector. It's 4 squared plus 3 squared plus a -5 squared. Okay? And I get the same thing. Don't do the same work twice. We already did this subtraction once. Just put the components in, square them, and add them up inside your radical.
What if you do? I forgot what I was going to say. Oh, if you do the bottom distance formula part, do you have to do the part above it? I mean, 'cause
No.
Yeah.
If that's the thing, it depends what you're asked. If you're just asked for magnitude, then we don't have to necessarily have this written out.
Right.
You're finding it as you do this, but
Okay.
it's up to you.
Yeah, so just, okay.
Okay? So that's another thing that we looked at in 2D. It's almost an identical process here in 3D. Okay? And that's really it for at this point. I've given you a little bit of practice. Find the distance from the origin, so find that position vector, in this case OP, and find the magnitude of OP in each of these. Alright, then you have some other magnitudes that you're finding. One thing about notation, alright, or I'm sorry, not notation, but vocabulary. The position vector of M relative to N. Okay? This is something that you may want to write down here. The position vector of M relative to N. That means N is your starting point. And we're going to M. Alright? Relative to N
Means it starts at N.
means it's starting at N. So in this case, A is really asking you to find the vector NM. Okay? B is asking you to find which vector? MN. Alright?
Which you can just make it negative.
You can.